Hello everyone, I am Siddhartha Chaudhary from Department of Computer Science and Engineering, Indian Institute of Technology, Kharagpur. I will be presenting on behalf of my team SEAL. Let me start by introducing my team members. Soumyati Ghosh, who is a second year PhD scholar student. Myself Siddhartha Chaudhary, I am a second year MS scholar. Anirban Chakraborty, who is a third year PhD scholar. Shubham Mishra, who is a third year BTech CS student. Dr. Somojit De, who is Associate Professor of CSA Department, IIT Kharagpur. And Dr. Devdeep Mukhopadhyay, who is a professor of CSE Department, IIT Kharagpur. In this year's CSAW Embedded Security Challenge, we were given a task to reverse engineer or exploit the backdoors of a firmware residing on a custom RISC-V based Wi-Fi access point as shown in the figure. We used a reverse engineering tool known as Ghidra. Now, out of the 19 challenges this year, we did able to solve 11 of them. We were able to classify the challenges into a few categories. Like SRAM was based on Morse code detection. Middleman was based on ECDSA signature. In case of quiz, we had to use an automated Python script. Sequence was based on Fibonacci sequence. Game was based on the blackjack card game. Impact was based on CSAW'20 hashing mechanism. Pursuit was based on secret hyperlink activation. And on the other hand, breakfast, burst, recycle and virtual one was based on string manipulation. Now till 31st of October we were able to solve this many challenges, but in the final report we will include a few more. Now out of the 11 challenges, let us explain the approaches of 3 of them. First, we will explain SRAM. In case of SRAM, we did decompile the binary of SRAM using Ghidra, where we did follow that there is a sequence of zeros and ones in the challenge function with occasional 2. Now at this point, we were able to identify that this pattern of 0, 1 and 2 are nothing but Morse code, where 0 signifies dot, 1 signified dash and 2 signified a change of word. We did write a Python script in order to decipher the Morse code. After running the Python script, we obtained that those strings gave an output of send the following over netcat remorseful. Next, we did find that there is a SHA-2 function which validates our input. What we did is we did use GDB multi-arc in order to extract the instructions of the function and compile it with a C driver program and emulate it using Kemo. After all these actions, we were able to find out that remorseful is our correct string. Now, when we did send the string remorseful to the device, it got validated by all those functions and we did get correct as the output. Now, this is the way we did solve the SRAM challenge. Now, in case of pursuit, we also did perform a decompilation using Ghidra. And we did notice that there are a few static variables which were of no use, and it consisted of a particular hyperlink. And next, we did identify the said hyperlinks from the variables. Upon visiting the hyperlink, we were redirected to a site pastebin where we were able to find a flag. And on sending that flag to the device, we found out that it was the correct flag. So this is the way we did solve the challenge pursuit. Now in case of quiz, we did notice a bit difference with respect to the other challenges. After a decompilation of the quiz, we did find that there is a set of questions which are bound to arrive one by one and we need to answer them within a bound time limit. Now it was evident that manually solving the problem quiz was not a solution. So we did come up with a solution of automated Python code where the automated Python code will be the client and the device will be the server, so that when every question is being asked by the device, the client will answer them within the time bound. So we did write the automated Python code in a way that suppose on every set of question, the Python code will identify those set of question using regex and answer them correctly within the time bound. And on receiving the answer, the device will fire another question until the challenge is solved. Now as you can see, when we did run this automated Python code, the client got connected with the device and every question was being answered correctly within the time bound. Now as you can see on the debug screen, after 9 questions, the challenge ultimately got solved. So in this way, we did solve the challenge quiz. So these were the approaches of the 3 challenges that we did say earlier. On a concluding note, we want to say that for the rest of the challenges, we did take a similar approach. So till 31st of October, we have solved 11 out of 19 challenges and we'll be trying to solve a few more in the final report. And for a few challenges that we weren't able to solve, but we did solve a part of it, we will include those details in the final report. Thank you for your time.